Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura and I'm joined by Antonia to talk about gems and whether you can tell the difference between lab-grown and natural ones, and whether there's any sort of difference in how valuable they are as a result. So Antonia, what's your interest in this?
I was looking for an engagement ring
That's exciting.
last year for myself. And, there's the ethical considerations, the famously Blood Diamond was a movie that kind of forced people to confront it.
Yeah, well, lots of people in horrible conditions and sort of dying because they're hunting for these jewels for some trader to sell to people in the West, essentially.
Yeah, so do you want to contribute to that? So if you don't, you can get a lab-grown diamond. And I thought, okay, scientifically, how similar are they? When I was speaking to a jeweler, they didn't need any specialist material analysis equipment. They just put on a magnifying glass, looked at it and was like, yeah, this one's natural, this one's synthetic, because inclusions.
From my sort of material science journalism background, because I'm not actually trained as a material scientist, so I haven't worked in the field for a while. Inclusions are basically like impurities, essentially, things that shouldn't necessarily be there if you had like pure aluminium oxide, say. And that means that essentially electrons are distributed very slightly differently in the structure of the gemstone, so it gives it a different colour.
Cool. I was honestly just so surprised. Just a magnifying glass was all they needed.
Yeah, I mean, again, with the sciencey work that I've done, you usually stick your sample or whatever it is in a machine that uses X-rays to diffract through it, and you basically get a spectrum out the other end of it, and you can use the peaks on that spectrum to try and identify what it is. That's how I do it as a natural... I keep saying natural scientist. I don't know why.
I suppose that's one way to describe someone who studies multiple sciences, though.
Yeah, and that was my original undergrad degree, but I didn't do a whole lot of material science in that, so I'm just confusing myself.
Yeah, X-ray diffraction. I can't quite remember how it works. Is it I call it like a destructive method of investigation?
No, it's basically like shining light through the sample, but it's higher energy light, hence X-rays. So do you remember doing the double slit experiment in school where you shine light through two slits and it creates a pattern on the wall?
Yes, and somehow the light gets split up into the spectrum and you can actually see the colours instead of just a white light.
I guess in some cases maybe, but yeah, it's essentially the same thing but on a much smaller scale. So you use the X-rays to diffract through the spaces between the atoms.
Wow.
And you get like a 3D or a 2D pretty pattern of spots of light on the wall or your detector, and some software just turns that into a graph.
I think I was getting confused with the prism.
Yes. That would just be bending the light through a different medium, I think.
This one's on a atomic level.
Yeah. So if that's the way I'm used to doing it with the material science, I'm also quite impressed that a jeweler can tell just by looking that something has, I guess, impurities or defects or something very slightly different about the crystal structure, that you I guess you're sort of kind of using your judgment to match what's happening on the atomic scale to what you can see by eye, because you can't see atoms through a magnifying glass.
Yeah, so I could only guess that whatever they can see is large enough at whatever magnification their magnifier is.
And you were talking about lab-grown diamonds, so I wonder, or gemstones in general, I wonder if the ability to grow them in the lab then makes a natural gem seem less valuable because you have more gems, and I kind of would assume that it's easier to get hold of something from the lab, but maybe not. I suppose it might depend on how difficult it is to grow.
So I had a look at lab grown. There's kind of a lot of different ways, but the first way I assumed was it would be high pressure, high temperature, because people always talk about, diamonds are formed under pressure, and it kind of is how, what's the word for it? Those types of rocks, and then you get quartz. Igneous?
Yeah. You would think I would remember that from my natural sciences degree, but it was too long ago, but yeah.
And so I assumed pressure, but actually there are cheaper methods. They've got one which the best I can describe is like a special crucible. They put in some powdered for sapphire and rubies. They put aluminium oxide in.
And using chromium, I guess, as well for ruby.
And you heat it up, and at some different points, you put in either hydrogen or oxygen, and you just kind of get a sausage of a gemstone. That's when I was looking up videos of it, because I was like, I've got to see how this looks. It genuinely just comes out like a long tube, well, solid cylinder, and it is one long crystal, one single crystal. So instead of like having multiple different crystals, they've formed one which they call a boule.
So instinctively, I don't quite understand why that would happen from just heating something up. Because normally, what I know from the material science journalism type stuff I've done, like if you're doing electronics, and a lot of electronics has crystalline structures in it, but you start off with the substrate that has the crystal lattice structure for the atoms, similar to what you want from your electronic device. So you start off with like a seed crystal, essentially.
This was something I couldn't pick up on, because I also thought, does it not require a seed crystal to get it to follow the pattern? And so you do kind of end up with a different crystal shape through this method. And to me, it kind of looked like molten glass. And then people cut it up into the nice, sparkly gems that you want.
Yeah, I wouldn't be surprised if there were like just various different crystalline structures in there, as well as just some random amorphous stuff which would make it look like glass.
Yeah, so the way people kind of use it, at least according to one jeweler that put out this explanation of how lab-grown sapphires were made, is they're only good for like small stones, maybe up to 2 carat, which is 0.4 grams.
Okay.
So pretty small, like, maybe up to a centimetre big. And so you can't really see how not like a natural gem it is, because you might get bubbles.
From what I've heard at various materials related conferences, it's actually quite challenging to grow a single crystal of like centimetres in size in the lab.
And I forgot to actually say what that method I was even talking about called. Just to put context in it.
Does it have a particularly exciting name that makes you intuitively understand what it is they're doing, or is it just a bunch of words?
It's named after a person called Verneuil, if I pronounce it correctly. The not named version is Flame Fusion, which makes it sound super cool.
I guess so, yeah. And I guess that distinguishes it from what you were saying about using pressure, which I assume would give you more control over the crystal shape that you're producing.
Yeah. So if you wanted the most perfect gemstone without inclusions and it kind of mimics the natural formation, you would use a hydrothermal method, which is lots of heat, lots of pressure, and you dissolve minerals in some sort of solvent like water, and then it grows into the shape, the natural shape.
I guess it's not as easy to grow gems in the lab as you would imagine.
No, it takes a while.
In practice.
The first one I mentioned is like one of the quicker ways to do it.
And how long does it take? Like days, weeks?
Yeah, on that kind of scale. And diamonds is different.
So then I guess that means maybe there is an argument for going for natural gems, because in theory they're just lying around, although someone has to go and dig them up.
Yeah, if you know where to find them.
But then essentially, if you're looking at how valuable something is, and let's say that you wanted to make a valuable gemstone in the lab, are you trying to create something that's already rare in nature?
That is a good question, because it might be you can get more specific colours that you want. Pink diamond is quite rare. If you know what the impurity, in inverted commas, impurity, the mineral that you want to add into it to make it pink, then it's a lot easier to just replicate, right?
Are they valuable because you don't often see them in nature?
I guess that kind of is what makes mined gemstones more valuable, because it's not as common. Then socially, you can be like, oh, look at this. I found this most rare, amazing thing.
But then I would also assume, because nature doesn't really do a lot of things really perfectly, like it's really good at just kind of going with random variations,
Yes.
that you would tend to find impurities in things in nature anyway. So I'd also imagine that something that's really pure is also quite valuable. So maybe that's another way of going about trying to figure out what the best way to grow something in the lab is if you did want to turn it into the money spinner.
Yeah, finding it naturally could be I mean, we literally have like searching for a needle in a haystack or trying to find a diamond in the rough. They're sort of sayings because it is so hard to get that perfect mix of colour and purity. But then for like in the lab, yeah, so colour could be determined just by like the little changes of minerals. So sapphire and ruby are both aluminium oxide, and they from the family of corundum. Sapphire we always associate with blue and ruby with red, and the difference with the ruby is chromium.
Okay, so they've essentially got the same crystal structure but different trace elements. So I can explain to you why that is.
I vaguely remember valence bands from electrons. Am I on the right thought pattern?
I think so. So they replace some of the aluminium in the crystal structure, which is in a 3+ state, so it's missing 3 electrons. But because they have a different valence gap, they essentially give off electrons with a different amount of energy, or give up their electrons with a different amount of energy.
Mm-hmm.
So they might have slightly different bond length in there, so they can absorb and transmit light at different wavelengths. So yes, what you were saying is pretty much accurate.
Yeah, and different wavelengths of light equals different colours. Yeah, diamond is different though, because diamond is just carbon, and carbon is pretty abundant. So how come no one's kind of got a bunch of carbon, made diamonds with it, and be super rich? That's my thought. Why is that not a thing?
My initial guess is that people desire them because they're difficult to get hold of out of the ground. Like, say you've got a really big diamond, or a funny coloured one, or a really, really pure one. If it's grown in the lab, and apparently the jewellers can tell if it's grown in the lab, then they're just not as interested.
Yeah, I guess if it's just mass produced, we're just not going to care as much. Yeah, I found this article from The Guardian about last year, and they've just seen decrease in price. And for lab grown, I would kind of say it's crashed. It dropped 74% since 2020. Natural diamonds also kind of had a decrease, but they also had a peak in 2022.
So I guess it just depends on how much people want to buy a certain thing as well.
They're sort of thinking in a way like, yeah, natural diamonds hold value better because they are harder to find. But historically, they've also crashed once people find more deposits.
Basic economics of mineral extraction.
Yeah.
I guess some are going to be judged as priceless because of their historical significance, like the crown jewels in the UK. So,
yeah.
Or the fictitious, was it the Coeur de la Mer in the Titanic, the heart of the ocean? Yeah, so I don't know if you could grow something in the lab that you could then make people want to desire. Like, say you grew something for a really famous celebrity, and they admired it and they wore it everywhere. Would that then make it more valuable? It's not very scientific, this.
Yeah, that's more of a social science thing. But then, yeah, people would make cheaper copies, sort of like how designer fashion gets replicated by fast fashion.
Yeah, I wonder, this is getting a bit weird, but I wonder if you did make something in the lab, you can like laser etch things inside of something.
Oh, okay.
If you have like 2 lasers that terminate at the same point in space, the amount of energy that they put in there sort of changes the structure a little bit, and you can see that. I wonder if you could kind of like basically imprint your diamond with something that you'd say, that's mine, that's definitely mine.
Sort of like a barcode to prevent theft, or just to make it more unique?
Either one of those. Yeah, like something you could only see under like an electron microscope or something. And the scientists do this for fun a lot of the time. We'll etch something really tiny, see how small we can get.
Well, what if you just etched it so it made a cool pattern in the light?
Oh, yeah.
Then that would be, something that you could control better in the lab.
Yeah, maybe that's the way to go, doing something that nature can't necessarily do. Maybe you need to stick a bunch of different chemical elements in your crucible and then see what you get.
A rainbow stone. Interestingly, I found a researcher who'd found a way to grow more crystal on an existing piece of jewellery.
Okay.
So you could basically upcycle your jewellery, and if you had a really tiny jewel, you could make it bigger. I found so much stuff on the secondhand market, and I thought if I was buying that brand new, that would cost like 5 times the price. What is up with that?
Yeah, I find it odd that something would be cheaper because it's essentially used. To me, a diamond is a diamond, right? Unless it's been owned by a Chinese dynasty at some point or something of historical significance like that.
Yeah.
Why would it be more or less expensive?
I think some people didn't like the setting, and so you're kind of stuck with it. Yeah, I guess part of the cost comes from the labour of the jeweller.
But then there's the labour of the scientists to grow it in the lab, and you just said it's not that easy to grow, so surely that should be equivalent. Just because it's less traditional doesn't make it inferior.
No, it doesn't, but yeah, it just kind of said to me, buying it might not be, inverted commas, an investment the way you think it would be, or people have said because it's so expensive.
See, the thing is, lab-grown ones can be considered valuable or strangely expensive too.
That's promising.
Yeah, so the most expensive one is $1.5 million. I think this is US dollars, although they don't specify, which is a pink diamond. It's one of the largest ever produced, and its unique colour and its size are what make it so desirable. It's 30 carats. I don't know what that is in grams. What did you say a carat was?
Divide by 5.
So reasonably weighty, I guess.
That's large. You wouldn't really be putting it on a finger. It'd definitely be more of a necklace or something.
Yeah, so $1.5 million for something that's really big or really has really good clarity or is just a funny colour. So I guess if you wanted to go down the route of trying to get rich from growing diamonds in the lab, that's what you need to do.
Just come up with a good one. Maybe names are good. I've got to come up with a good name and story.
Yes, and add to that sort of the social value side of it.
Yeah. I was also thinking then the opposite, because also prettiness must be a factor, so like super sparkly. I was looking at like how some of these lab formed ones, particularly the flame fusion, they didn't look that cool.
Did they just look like kind of dirty rocks?
No, they weren't dirty rocks. They just kind of looked like slightly hazy pink or blue glass. And so that might be how people make like sapphire glass or, hardened materials or diamond drill bits, I guess.
Maybe. I've never really thought about... I assume it's just diamond coated rather than completely made out of carbon. But I've never really thought about how toughened drill bits are made.
No, but then I thought, how do you make... Like, do you just get a bunch of diamond dust? But then is that just carbon at that point?
Well, it's carbon with a specific crystal structure.
Okay, yes. I think I'm just going back to how other things are made, like chemical vapor disposition.
Oh, so yeah, I think that goes back to what I was saying. Like, you start off with your seed, your substrate, or your seed crystal. Have it in a vacuum and release very small amounts of whatever oxide you want to put on top. That's often how a lot of electronics are produced.
And I think... No, I'm getting it confused with a different method to make the monosilicon for semiconductors and solar panels.
Yeah, I don't think you're going to make a lot of money from producing silicon-based anything, though. There's too much of that around, isn't there?
I don't know. Getting the high purity for semiconductors, there are not that many semiconductor manufacturers, so there was that shortage because there's only a couple that have the equipment to do it at that scale.
So are you saying don't go into gemstone production, go into the silicon electronics market?
I suppose gemstones at the heart of it are a luxury item.
But I'm sure I've seen some electronics that are grown on either a ruby or a sapphire substrate.
Oh.
So you still need your gemstones in there somewhere.
What purpose do they serve there?
So the substrate gives you the correct starting crystal structure to grow your electronics.
I assume they used the same material, like silicon.
It depends on exactly what they're trying to create. I mean, if you've ever looked at how solar cells are constructed, they have like different layers of loads of different stuff.
I have, but I didn't really look into. I just kind of went, it's a silicon layer. That's what I will leave it at, because that was all I needed to know. I didn't need to know how it's made. I need to know its environmental impact.
And I guess if you wanted to make money off this, you're going to have to start cranking out an awful lot of electronics. But then, in contrast, you could probably just spend your time trying to figure out how to make one really big gemstone, make all your money off that, and then retire straight away.
Okay, yeah. Do you put all your eggs in literally one basket?
To me, it sounds like it would be more fun to try and grow a really big diamond than it would to produce thousands of silicon chips. So yeah, I'd definitely go with the eggs in one basket thing.
I wonder if, this list that we found with the most expensive lab-grown diamonds, were they all by the same lab just trying different things?
You would think they'd get bored eventually. I can't imagine that was the lab's sole purpose, to make loads of money producing gemstones. It sounds like someone's side project.
Maybe they work in a fashion house or jewelers and their sole purpose is to make things to put on the red carpet, because now is the film and music award season. So do they just crank them out for red carpet looks?
Oh, I can see that being a thing. Wouldn't that be nice if you only had to work like once or twice a year doing one thing that you're really good at and then making loads of money from celebrities that you could then use to fund your sustainability initiatives?
Oh, but you have to plan in how long it takes to grow each one.
Yeah, like you just set it off and leave it every 6 months.
Yeah, maybe you work for a few months because it takes a couple of months to grow and then you're sorted. Maybe whenever energy is the cheapest.
I was just going to say, if it's what, at like 1,000 degrees Celsius to produce these things, and you're saying it takes weeks?
Some of them were over almost like 1800 degrees. And then I saw some really dubious numbers for the pressure, and I'm pretty sure there were some errors. They said 800,000 pounds per square inch, which translates to like 58,000 bar. And I thought that can't be right. Someone's written the wrong number down somewhere and just copied it everywhere.
Yeah, so some of them did use high temperature and high pressure, though.
Yeah, so diamonds can be grown with high pressure and high temperature. And the most fancy way of growing sapphires and rubies, the hydrothermal, also uses high pressure to force minerals to dissolve.
Because right near the start, when you were talking about that, what was it, the flame something or other?
Flame fusion.
Yeah, that's just high temperature and
That's just high temperature. And some gases.
Okay, so I guess you'd need to research very carefully the best technique for whichever gemstone you wanted to make. So it's probably not as simple as we're making out.
Well, people were saying for jewelers, they could just do the flame fusion in their own workshop. So if you just want to get started, but it's not going to be the fancy ones.
I would say that if you did want to make your millions from this, you don't want to be cranking loads out anyway, because they use market saturation. The more you make, the less valuable they become. We were talking about mass production before, weren't we, and how people want less of that.
Yeah.
So yeah, you need to make your gemstones seem more desirable, like to like celebrities we were talking about.
Yeah, basically hitchhiking on some sort of great storytelling.
Yes, so you're not just growing your gems in the lab, you're doing the thing that I always find we like perfume adverts, when they're trying to make something really desirable, you just sit there thinking, well, that's just weird.
I think they call it like crafting a lifestyle that seems desirable, but they're just weird ads. But maybe we're too logical that we don't understand how a piece of fabric floating on the breeze is how I want to smell.
That's not a thing I really want in my life. I want sustainable things that don't cost the earth and harm the environment. Thank you very much. How is your perfume sustainable? Tell me that.
This is off topic, but I quite like the smell of jasmine, but apparently jasmine is not something that you can make sustainably. So everything is a synthetic version of jasmine, unless it's really expensive.
So you can't just harvest some jasmine flowers?
Apparently the chemicals don't stay that way, which I can verify. Me and my mum were at a flowers market in Hong Kong, bought some jasmine. It smelled great. We left it in the bathroom. Then it smelled rancid.
Oh.
It decomposed so fast.
Maybe that's a new episode. Are natural smells actually better than something that you would grow in the lab? We could do a whole theme on this, nature versus lab grown.
I mean, yeah, a lot of synthetic, like some of the flavourings that we know are actually synthetic and not real because they couldn't actually get that into a product. Another way to use chemical engineering.
I think we've definitely gone off topic, as you said, so we should probably leave it there. So what we're saying is that there are lots of different ways to grow gems in the lab, but they're more valuable the rarer they are. So if you did want to just grow a load of stuff in your home laboratory, you couldn't just crank out a load of them to make your millions and millions of dollars or pounds or whatever denomination you want to work in. You need to make it seem really desirable by creating some sort of weird story around it, which as scientists we just don't do. So on that note, of not crafting a great story as scientists, but hopefully having some compelling science conversations, we'll leave it there. Thanks for listening and we'll see you next time. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.